Question 3. Traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f defined below. F of t is measured in cars per minute and t is measured in minutes from 0 to 30. So I'm going to start by putting f of t into my calculator as y1 again. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? So we want to integrate our rate to get the total number of cars. So we want to integrate 0 to 30 of f of t dt. And I'm going to do that on my calculator, and I get a nearest whole number car, 2,474 cars. That is part A. For part B, is the traffic flow increasing or decreasing at t of 7? Give a reason for your answer. So we want to know if the traffic flow is increasing or decreasing. So we're going to do f prime, because that tells us whether the slope is positive or negative at 7. So we can do that on our calculator. You have it plugged into your calculator already, so you can either find your derivative or type it into your calculator, and we get a value of negative 1.873. So traffic flow is decreasing because f prime of 7 is negative. So the slope is going down. Part C, what is the average value of the traffic flow over the time interval 10 to 15? Indicate units of measurement. So once again, I'm going to use my formula for average, 1 over b minus a to b of f of x dx. So we're going to say 1 over 5, 15 minus 10, from 10 to 15 of f of t dt. I'm going to do this on my calculator. We get 81.899, and this would be cars per minute. It didn't specify to round to the nearest whole number, so I'm going to keep it at a decimal there. Okay, so part D is asking, what is the average rate of change of the traffic flow over the time interval 10 to 15? So the question C asked for the average value of the traffic flow, so we did the F average equation for our traffic flow equation. Now I want the rate of change, which is going to be the derivative. So now what we're going to do is still do the 1/5, 10 to 15. Now we're going to do F prime of t dt. Well, that's ultimately going to be 1/5 times f of t. When I integrate f prime, I get f from 10 to 15. And when you plug your values in, you get 1.518 cars per square minute. So on average, every minute, that's the rate at which the rate is changing.